All right. Seems like we are up and running. Let me quickly check. I think it's working. Yep, seems like that. So it's Friday night, which means, as you might guess it, all right, it's time for another coding challenge. Let's go! It's streamed for entertainment purposes only. We have 40 minutes to try not to crack another problem today. And let's see what we've got. So pick one. Here we go. Ah, it's hard. Oh no. Anyway, we are not supposed to crack it. At least we can try. Suppose that LeetCode will start its IPO soon. In order to sell a good price of its shares to venture capital, LeetCode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, it can only finish at most. Oh no, oh no, already sense a little bit of dynamic programming here. So it can only finish at most K distinct project before the IPO. Help! LeetCode design the best way to maximize. Okay, it's optimization problem, it's dynamic programming problem, 99% confidence. To maximize its total capital after finishing at most K distinct projects. You're given several projects. For each project I, it has a pure profit PI and the minimal capital of CI is needed to start the corresponding project. Initially, you have W capital. When you finish a project, you will obtain its pure profit and the profit will be added to your total capital. To sum up, pick a list of at most K distinct projects from given projects to maximize your final capital and output your final maximized capital. So quickly, one more time. You're given several projects. For each project I, it has a pure profit PI. That's why we have array PI. And the minimal capital of CI is needed to start the corresponding project. Initially, you have W. When you finish a project, you will obtain its pure profit and the profit will be added to your total capital. Okay, my headphone seems to go die soon, so stream may be shorter than I think. Of at most K distinct project from given project to maximize your capital and output your final maximized capital. Right, so example, input K2, W0, profits 1, 2, 3, capital 0, 1, 1, 1, output 4. So we can use 1 plus 3, W is 0. Index 0. After finishing it, you will obtain profit 1 and your capital becomes 1. With that capital, you can either start the project index 1 or the project index 2. Since you can choose at most 2 projects, you need to finish the project index 2. So it will be 3, right? So the total index 2 to get the maximum capital. Yes, the 4 output of the final maximized capital, which is plus 0. What do you mean by plus 0? 1 plus 3. Right. And W amortize this. On non-negative integers, obviously, profits are in capital I will not exceed 50,000. The answer is guaranteed to fit in a 32-bit signed integer. So capital array will not exceed 50,000 sounds like you need 50,000 to get the maximum profit. So we have W, right? So this is our capital. W plus all the capital values is the what? Is the maximum capital, is the maximum constraint, the maximum capital we can get in case 2. All right, let's switch to the whiteboard. It's not an easy one. So so one of the keys here, right? As we want to maximize capital, and the number of projects is limited, right? So let's imagine that we don't have constraint on the capital. So then the problem becomes very trivial, right? So no constraint, no capital constraint. Then it's just max and max second plus third plus it and so forth until k, right? So straightforward, can be done in ON. It's not about this. So what capital adds to the problem? So the capital adds the constraint at which some of it may not be used, right? So but then profits allows us to use extra capital, right? So profits add to capital, sorry, to W basically, right? So whatever have been chosen, it adds to W. And then, yeah, okay, of course, the simple one, I guess, would be go through all possible combinations in some exhaustive search manner, find the maximum one. Also the question, if let's say k is equal to, does it mean that there is always a case that 2 is better, 2 selected project will be better than just 1 selected project? I think so, because profits are always positives, right? So they're not negatives, that's what we know. So it's always good to have maximum of k. So k is always guaranteed. So how many projects we can select is basically k, right? So we need to select k from profits, All right. Seems it works. So let's return back. By the way, let me quickly reduce the sound. All right. So the idea is, so we need select key, right, from profits. This is our, so the maximum profits we can get obviously is this, right? This is max, assuming no constraint, and it can be found in or n time basically. Um, hmm. So if we know that we need to select k elements, right? We have profits of size something, let's call it m. Then what's the question we may ask? Well, the question would be if adding element k or the project I to k increases the capital and at the same time minimizes so okay, imagine this scenario, right? So this is trivial, and let's say we don't care about this we can just say that this is the maximum capital we can raise is just the sum of all profits, no matter this is just the upper bound, right? It doesn't mean anything. So what we want to say eventually is, so let's say we know that the profit is like in this example, right? We have this 1, 2, 3, 1, 2, 3 profits. You can also add 0 profit here, so it doesn't matter. So we don't even pay attention to this. So every time we select something, right? Like for a number of projects selected, like if we select all of this, it's just the sum of all profits, right? Like how much? 3 projects selected, 2 projects selected, 1 project selected, 0 project selected. If it's 0, then the profit is also 0. If all selected, that this is the sum of profits. So the problem is that if we select 2, let's say out of 3, then what? Then we have how many? Right, so if we select 1, so what if it's quadratic here? Let's see, if it's 50,000, it implies somewhat like quadratic. I would say deep dynamic programming or something like that, right? So let's say on one axis we have num of projects, right? 0, 1, 2, 3. On another one is profits, so it's also 0. 0 profits, or maybe should those be elements? Yeah, let's assume those are elements. It's just the coincidence that they're the same, right? So we say, okay, if we select one project, so if we select 0, everything is 0 here, obviously. If we select 1, now this is 0, this is 1, this is 2, this is 2. If we select 2 now, right? Select 2. So what this means, if we select one project of this is what this is J project, right? Which exactly project we select? If we select 2, in this case it was 1, the previous project selected, right? And it was max among this, right? And this one, which is 3. This is 4. This is 5. This is 6. But the problem is every time we select max, it should feed budget. Max under budget. Under budget. Right? So in this case, it will be, so the only thing fits is 1. So here is nothing. So here maximum under budget will be equal to 1. Right? And this is obviously just numbers. So in this case, the 2 will be what? If we select no more project, it will be just 1. Then if we select one project, it will be what? One project, and technically it's been selected already, so it remains 1, right? So that if we select second project, and the capital allows us to do that, it will be 3, and this is 4, right? And we definitely don't check 3 because k is equal to, right? So this is from 0 to k, so we don't need this, and then we just find the max out of this row. Sounds like trivial. Do it work all the time, and especially this part. I wonder if it can be done in ORN or something like that. The search of how many project will be fitting under the budget. Most interesting part goes to 3. What if actually I can select, let's say, this project and this project, 1 and 2, and then 3 here, or if we have 4, right? Maybe it's 1, 4, and then 3. We'll see. We'll see. All right. Let's go to the default scene. At least maybe we will be able to crack the initial example 1. So it will be 1 out of whatever. And we have roughly 20 something minutes left. We can give 5 minutes back due to change of headphones. All right, so let's imagine we have int this is k, and this is we said what? Profits size. This is k in a sense that it's k plus 1, which is initially 0. And obviously we can initialize it as zeros, whatever. I guess it's like this, if I remember correctly. Return dp. This is what? This is k. And let's say 0 or whatever. It would work this way. I mean, just the compiler itself. No. Right. Init array cpp of size for dummies. Yes, that's what we need. Not like it's the number. Init to the array of cpp set is stack overflow to new int xy. That's what it says. At the compile time. Weird. Maybe it still doesn't like this one, and I guess default for int. I know it's random, but whatever. All right. So let's go backward and say init array of 0, 0 cpp. Can I just say this? I wonder if it's gonna work. Most likely not. Nope. No, it just says this. Doesn't work. Okay, whatever, let's not spend time on this. So, right, so for Let's go. Have we already have k, right? Let's say k 0, k less equal k less equal k plus plus, and then another array, sorry, loop cycle, and we say int, let's say call it j, or we can call it I according to the description. All right, so if kk equals 0, so it's basically one off, all we say is dp of kki equals 0. Straightforward. Think not interesting. So it's basically initial condition when we do not select any no project selected, or no projects, no profits. So else, so kk is at least 1. Now we need to check that int, let's call it budget, which is equal to w, right? So now we need to check and then we should have, so maybe the budget as well as the as this thing, right? Let's call it dp, and it's exactly the same size, and let's call it budget. So what do we know in terms of budget? Well, we do know that the budget initially is equals to w. That's what we have. Else, so if you go to k1, then we need to check that if we select, so basically what we're saying, so we know that we select right now one project, and let's say we select I. All right, if select project I, then we should check that if capital I, right, is less than the budget kk minus 1 I, right, or equal to then what do we say? So we select some projects before, and now we go to project I, right? Then we say KK equals to, right, on the project on the prior selection step for the position I, plus what? Plus, or maybe we should select the max here, but this will be already like too much. All right. So how do we do that then? Maybe max here. So that it will be the I plus profits I, right? So every project should be selected just once. And we somehow should maximize the prior step when we, let's say, select just one project. Because selecting one project is basically easy. Find the maximum value that fits under the capital, right? If you have two, now it may be a little bit more trickier, right? Or should we bother? That's the question. Because at every step we want to select the next max available, I guess. Maybe no. And we still want to track if the various budget combinations, right, that can yield us something more interesting. This hope. All right. Let's return to budget here. So the budget is what? Is minus capital I, right? And plus profits I. This is what it is. And then if we can allow due to the budget, then I next step would be what? Then the budget KK remains the same, and the profit we get from this remains 0 because we haven't selected anything. Now it's still half the puzzle here, because now we track the budget changes as part of changes in whether we have selected or do not select it, right? But then But do we really need track it stage by stage? That's the question. Can we say that the budget it just depends on I, right? So for every project, because we can select every project at most once, then maybe we don't even need to track it, or do we? We select something here and then we go to the next stage, right? Like let's jump back to the whiteboard. So let's imagine we have selected and one, let's say for some reason we have selected this one here. So what it gives us, so for this one then, right, we don't really care. Or maybe we do, maybe we can have extra that after we're done with this arrow, we go here, right? So this cycle is added, and then for this specific value, we find this maximum and then use it next time. Should we? That's the question. And the profits, I guess, just remain the same. That's what we should do, right? So should it be the maximum or not? So if we already, so let's ask a different question. So if we already know, let's say one project that was selected, do we know the second one that needs to be selected specifically? Like in this case, if I run stuff, I will end up basically with what? That we select, we go for cycle, right? We select, obviously we just file this, and this is 0, this is 0. So we go here, capital S, we go to budget. It only goes for the first one. So we add profits to the first one and then budget to the first one. The problem is budget is more like some k minus 1 step. Do we always select one by one, or do we? Yeah, I don't see any. Because if selection of the next project is always predefined by the initial projects, right? Then initial project selection is always doesn't depend on the future project that we select. It's just purely driven by what we allow and what's the maximum profit that fits under the budget. Then it can be very trivial. Just basically select this one, go to the second one and check if you allow it, and then if we subtract profits from capitals, because that's what we're gonna add, right? And then Okay, so returning back to this, so we know that the budget now becomes 1, and once we move to the next stage, we now should be able to select those projects so what if our dynamic programming assumes that this is a starting position? So we first start selecting 1, 2nd, 3rd element or whatever, right? And every time we move by step, we kind of add, no, it gets too tricky to hold. So let's imagine we don't have K, right? Yes, but then all possible perturbations too much. Yeah, it's not easy. I mean, basically what I'm thinking is, again, sort of exhaustive breadth first search or depth first search, where you start with 1 and then go through other elements available until it fits the capital, and then you return the max one. But this is exponential. This is exponential. This should be something easy. I just don't find the right answer for this one. All right. So let's then do the exponential version. Yet again, int exhaustive depth first search. Oh gosh, never solve these dynamic programming problems in time. To me, it feels like impossible. Int so let's see, it's order set int selected, those that are already selected, right? Then int their profit, right? Profit, total profit. Let's call it TP for shortness, and budget remaining. Let's call it RB, remaining budget. And obviously we need this all except W, because W will be as part of remaining budget. So what do we know? Obviously, if selected size equals K, return return what? Return total profit. All right, it's an easy one. If not, else, so it can be greater because we will return it then. For int I equals 0, I less than Oops, what have I done? What have I done? Let's go back. Nope, lost everything. Jeez, stupid secondary buttons. Okay, history, where it was. Nope, it was 5000 something. 502, right? Oh yeah. Come on. Should be there, the answer. I mean the code. Right, so I is less than profit size. I plus plus. Right, kind of 5 minutes, but then it's okay because we adjusted our headphones, so I guess I will be able to code this one, fail again, and then we can check what's the smart people do. I plus plus. So what do we do? So we also have int max. Int max equals 0, right? So then we say max equal max profit. Max profit equals max p and EDFS again, right? Obviously, if it's selected, find I not equal selected, and actually it's pointer, so, and we continue. We don't need to go this route already. So then we selected EDFS. If it's not, then we say selected if I add it here, right, and then send it to this guy, all right, then we also need int current or something, current I, and then before we add, we say selected, insert current I, and then we do the checks. So I, which is the current I, selected, total profit. Now we should say if we select this guy, right, and then what's the total profit is, so we select this guy, right, then we say TP plus equal profits current high, right, and remaining budget, because we have selected this one, right, is plus I, also profits, because we now can add profits to our remaining budget to do other projects, right? And K is just K, doesn't change, as well as capital. So where the capital plays a role, it plays here. So if remaining budget is greater or equal to the capital I, right? So we can afford this project, then what do we do? If we can afford this project, we do this max if selected, right? Total profit, the current total profit, which initially is 0, and remaining budget will be what? Remaining budget minus capital I, because we kind of subtracted, right? And then what? And then we just type K, profits and capital for the next one, right? So profits is used here at the when we compute the total profits. Then remaining budget, and then capital is used here, right? Nice, nice. And then once this is done, we return max P. All right, nice. Sounds like a doable plan. So this then is just what? Maybe some corner cases, but basically return EDFS the problem is so we need some conditions here. Car I greater or equal 0, then we basically fill with the budget, right? And then selected size K plus 1 is here, or we can just, maybe we don't need this, we can just specify it here. So we start with -1, basically no elements selected, W. W is the remaining budget, 0 as the total profit because we have nothing have selected. Selected. Right. I think I've been selected. Remaining budget is W. And then what? K plus 1, because we have this -1 element that is technically doesn't count as anything. Then profits, then capital. So here we go, exponential complexity, ladies and gentlemen. See if it works, at least. Maybe pass one simple small test or something like this. Yes, yes, yes. If OK, return TP, run code. So it returns 3. Interesting. Did I say it K plus 1? Yes, I said this. It's so interesting why it doesn't work. So for this specific example, we can debug it simply by cout selected project current I, because we know that in this case we will select just one at a time because W is 0, so it won't allow us to branch multiple ways from the beginning. Let's see. Selected project 1 and selected project 2. We branch, yes. But then, isn't ooh, so we return max, it returns here, and then it compares max p to this guy, and then tries one more time. And then let's say TP equals 2, right? And then we say TP. I think something on the return condition is wrong. Total profit 1 in both cases. So the max doesn't work, sounds like. Because when it return, so it will return both. It will return 1 and it will return 2, right? So let's see. Int car p equals to this guy, and then this is the car p, and then we log another thing here saying what? Saying profit, or total profit, or max, let's call it max total profit, and current total profit. So we return first when we select 0 TP 0. Obviously, we start with selected project B0, then selected project 0. Interesting. So when we go to selected project 0, right? This TP0, which is obvious, but then it adds to this, which is 1, right? So, there we go. I think it's this. What I'm missing is, it's not 0, it's TP, right? Let me run one more time. Maybe? Any chance? All right, output 4. Now it works. Nice. Yeah. Sounds like my laptop is gonna die, so one last chance. At least we passed one thing. Quickly remove this and remove this. Run code, make sure it still works. And now submit and see, of course it will fail because of the time limit exceeded. I know, it's wrong answer. Interesting, but okay, we are out of time. So let's see how many tests we have passed, if at all. 0. Oh, come on. All right, we passed 10 out of 33. So the 10 out of 33. Oh, I didn't even switch the scene. So, okay, let me quickly show the code. So this is exhaustive depth first search.